Hello guys, welcome back to another week of New Horizon tutoring videos. Again, if you don't remember, my name is Liz, and today we're just going to be doing some more math. So last time we just went through some notes about kind of like the basics of circles, arcs and sectors, stuff like that. And then we were able to get in a couple practice problems. So today we're going to be going over the same stuff, but it's just going to be all practice. So we'll just see kind of how many we can get through with the time that we're given. But yeah, there's just like problems over circles in general, a lot of different subtopics within there, but basically what I did again is I just went through in ACT practice books and picked out questions about circles that I thought represented kind of like the majority of what the ACT is going to test you over and what the ACT wants you to know about circles specifically. So yeah, there's kind of a range. Some of them are a little bit easier, some are a little bit harder, some take a little bit more time than others, but again, all really important concepts that we're dealing with. So you guys kind of know the drill. I'm just gonna go ahead and write one problem at a time up on the board, and then I'll just kind of walk through the explanation behind how I got to my answer, and then we'll take a look back at the problem when we're done and kind of discuss like the more or most efficient way that we can solve that problem for the actual test, because that's what you guys are gonna be actually required to do. So yeah, we're just gonna go ahead and jump into it. Again, make sure you have a notebook, something to write with, your graph and calculator. We're not working out of the ACT Math packet today, so you really don't need that. If you have it, that's cool. But we're not really gonna be working out of it, so you don't necessarily have to have it for today. Okay, so this is the problem that it gives us. It says that a circle has the equation of x minus 3 quantity squared plus y minus 5 quantity squared is equal to 25. And it wants us to find the distance from the center of that circle to the point negative 9, 5. Okay, so we're gonna go ahead and get into this. The first thing I'm going to write down, just to remind you guys, is the general equation of a circle. And that is this right here. Oops. X minus h quantity squared plus y minus k quantity squared is equal to r squared, where hk is going to be our center. And r is going to be our radius. Okay, so again, that's super important information, not only for this problem, but just important information to have in general in dealing with problems about circles. Not always are you going to have to apply that equation, like whenever you deal with a circle. It kind of depends upon like which branch of geometry, I guess it's in, whether it's like coordinate geometry, which you are going to have to know that equation, or if it's plane geometry, which is dealing with like less of circles on coordinate planes and just like the shape in general. So yeah, just make sure you know that equation, and from that equation, and specifically from the information of what we know about the center, we're going to be able to solve this problem. Okay, so since it's asking us to find the distance from the center to this point, we obviously have to figure out, okay, what is the center of our circle? So if we look at the equation that they gave us for this specific circle and compare it to the general equation of a circle, we come out with our center point pretty easily. We know that it's going to be, oops, I messed this up. Sorry, I just changed that minus sign to a plus sign on the y plus 5. But we know our center is going to be 3, negative 5, And the reason it's going to be 3, -5 is, again, we have minus h minus k here. So just make sure that you're keeping those negative and positive signs straight. So yeah, now we know our center, and then this is the other point that they are dealing with. So these are our 2 points, and I don't believe we've gone over this yet, but you may have already learned it kind of just like in passing, or in school or whatever setting. But there's actually an equation that we have that can help us find the distance between 2 points on a coordinate plane. So I'm going to go ahead and write that up here. So this just reads as the distance being equal to the square root of x1 minus x2, quantity squared, plus y1 minus y2, quantity squared. Where we have x1, y1, x2, y2, serving as our 2 different coordinate points. Basically, all we have to do, if we know this equation, is just plug those specific coordinate points into our actual equation and solve it out. So that's exactly what I did, just plugged in my coordinate points to the equation. Make sure you're careful with like negative signs, double negative forms of positive there. And then here we have -5 plus 5, so I know -5 plus 5 is gonna be 0. So I don't have to worry about that one. So now if I simplify it down, I know 3 plus 9 is gonna give me 12, and we still have that squared, but since we have a number being squared under the square root, those two functions, those two operations are gonna essentially undo each other. So now we're just left with 12 as our answer for this problem. So again, what does 12 mean? 12 is just the distance between this point that it gives us and the center of the circle. Okay, so that is that problem. Kind of looking back, I would say the way to do this most efficiently, obviously you don't have to like write out all of this stuff, that was just to kind of show you guys. I would say just to make sure to like write out your 2 specific points. Make sure you like I said before, keep your positives and negatives straight from your center point. And then yeah, you don't even have to really write out that general equation if you already know it. I would say don't do like the mental math in your head, because that might get kind of weird with like adding and subtracting, stuff like that. But I would say either like write this part out, or you could just go ahead and type that into your calculator and then get your final answer. Okay, so that is number 1. We're going to move on to number 2. Okay, so gives us this problem here where we have essentially a big circle drawn here, and then like a little wavy line in it, and that kind of curved line is just going to be composed of 4 equal semicircles, 4 equal half circles, and it tells us that the circumference of the entire circle is going to be 24 pi, and it wants us to figure out what the actual distance along that curved line is. Okay, so first things first, It tells me the circumference of this circle, but I want to find the diameter, right? Because this straight line across here is going to be my diameter. So even in just looking like for the distance along the curved line, we can infer that the diameter is going to be pretty important to that. So like I said, they told us our circumference is equal to 24 pi, and we know that the general equation for our circumference is going to be pi d. So I'm basically just going to set these two values equal to each other. And I can see pi on both sides going to cancel out, and I get d is equal to 24. And again, I just know that 24 is my diameter, so it's going to be the length of that straight line along the circle. Okay, so now we kind of have to figure out exactly what we're looking for as we're looking for the distance along that curved line. So if we think about it, since it's going to be distance around the outside of those semicircles, essentially what we want is the circumference of one of those semicircles, right? Because we know that they're going to be equal to each other. So once we find the circumference of one, we can just multiply by 4 to get the whole line. So that's basically what we're going to do. So like I said, 4 equal semicircles. So I know that this line is divided into 4 equal parts, right? So if I take 24 divided by 4 is going to get me 6 right here, right? For my diameter of one of those semicircles. So now from here, again, we can use our circumference formula. C is equal to pi d to find the circumference of one of those half circles. So, like I said, the circumference of one of those circles is going to be 6 pi, but here's the kicker. That's going to be the circumference of one of those circles, one of those mini circles, if it was a whole circle, right? Because we're just dealing with like normal circumference of normal circles in this equation, but that's not what we want, right? We only want half of it because it's a semicircle. So basically what I'm going to do, since I want half of the circumference, is divide by 2. So that's going to give me 3 pi for the circumference of one of those half circles. So then from there, like I said, we know that we have 4 of those half circles, so we multiply by 4 to get our final answer of 12 pi, and again, 12 pi just standing for the distance along that curved line within the circle. Awesome. Okay, so that's number 2, kind of looking back at it. Obviously, like if you know the area for circumference, or the formula for circumference, you don't have to like write down all of those little steps. You can kind of just tell right away this is going to be 24. Just make sure you're really careful about what you're dividing by, like what you've already divided by. This is a really important step. Make sure to divide by 2 before you multiply by 4. Or if you recognize that, you could even just say, okay, if I'm going to divide by 2 and then I'm going to divide by 4, I could just, or going to multiply by 4, sorry, you could just multiply by 2, right? Yeah, just make sure you're keeping that straight. Don't sacrifice getting the correct final answer for shortening it up like a few seconds on time. Okay, so that is number 2. We're going to go ahead and move on to number 3. Okay, so here they give us this diagram on the XY coordinate plane. It wants us to find the equation of the circle where it's essentially kind of enclosed by three lines here, three tangent lines here, right? Our y-axis, our x-axis, and this line that they drew here to form this kind of right triangle of sorts, where we have points A, P, and B. Point A is going to be at 0, 8. Point B is at 6, 0. And the distance between A and P is going to be 6. Okay, so we're going to go ahead and answer this question, kind of work through it. And this specific problem relies heavily on just kind of knowing relationships, not as much equations, although obviously it is going to deal with the equation of the circle because that's what it's asking for. But like I said, it's really just kind of more relationships of circles in general, which is why I really like this problem. I think that's obviously a really important subject to cover because kind of knowing like the equations and formulas of things can only get you so far. You have to know kind of like the rules behind them and the relationships behind them, and obviously how to like actually apply them to problems. So we're gonna go over a couple specific relationships dealing with circles in this specific problem. Okay, so the first kind of rule or relationship, or however you want to think about it, is what I just wrote up there. And that tells us that tangent segments that span to the circle from the same outside point are going to be equal. So that's essentially what we have happening here, right? We have two tangent segments, this one here and this one here, both spanning from that same point A. And again, since they are tangent to the circle, and they come from the same point, they're gonna have the same length, right? So we know that AP is gonna be 6, so the distance from A to where this circle is tangent here is also gonna be 6. Okay, so you might be saying, well, why is that important? It's gonna be important for a couple reasons. The first is this, that if we know that this segment, this larger segment is gonna be 6, and we know that the entire segment from the origin to A is going to be 8, right? Just because that's kind of based off the actual coordinate point. We know that this little segment here is going to be 2. And that kind of unlocks the rest of the problem for us. Because if I know that like this segment here is 2, I know that this segment here is also 2. And that happens to be our radius, which is super helpful. Because if you think about it, we really need two things to find our equation for our circle, right? We need the radius and we need the center. So we already found the radius, we're good with that. And actually, if you think about it, if you draw another radius here that is perpendicular to the y-axis, that's gonna have the same exact measure, right? All radii, no matter where you draw them on the circle, are going to have the same measure. So if the radius is 2 here, radius is also the 2 there. Pretty self-explanatory. And actually what that does is it shows us where our center is, right? Because we drew those radii from the center of our circle to the outside of our circle, and it happened to be that our circle was tangent to the x and the y axes in those points. So we know that the center of our circle is going to be 2, 2. So now I'm basically just going to plug that information into the general equation of our circle, and that's going to be our answer. So our final answer for this problem is x minus 2 quantity squared plus y minus 2 quantity squared is equal to 4. Okay, that's that. Looking back, just kind of reflecting on like what we just dealt with, how we could have maybe done it like a little bit more efficiently for the actual test. Obviously, you won't write that out. I just did that to kind of show you guys that relationship. But that relationship is super important. If we didn't know that, in essence, we wouldn't be able to solve our problem, right? Other than that, I would say that it's just really important to make sure you actually like mark up your circle and your triangle. Just make sure that you're like translating all the information that they give you and all of the information that you find out onto that actual diagram, because it's going to be really helpful for you to kind of visualize, to see what you already know and use what you already know to find what you don't know, what you need to know to solve the actual problem. Okay, so that is number 3. We'll go ahead and move on to number 4. Okay, so here we have a circle enclosed by a square, and it's going to be tangent to the square on all those 4 points, and it gives us a distance from the center of our circle to one of the vertices of our square, and it just calls that x, and then it wants us to find the length of the radius in terms of x. So when we solve this out, we're not going to get like an actual value out. We're just going to get, we're not going to get an actual number value. We're just going to get a value that contains x, our variable, in it. So yeah, we're just going to go ahead and jump into this. This problem does, in fact, show us again the intersection that is so prevalent between circles and triangles, the relationships between the two, how we can use our information about triangles to solve problems dealing with circles. So yeah, we're just gonna go ahead and jump into it. Okay, so in essence, what I just did is I drew one of the many radii that I can draw on my circle, where it just spans from the center to one of the points on my circle. I just chose this one because it's easiest. And it actually is at a 90-degree angle to one of the tangent lines that composes our square, and it hits exactly at that tangent line. So basically what I did is I just created a right triangle with 2 equal sides here, and that makes sense, right? Because if we think about like this in terms of our radius, this length here, or let's just call it, this length here would also be our radius, right? If I drew it like that. So since this would have the same length as this, has the same length there as well. So just important to know that those 2 sides are going to be equal, because that leads us to the relationship that we're able to deal with next. So basically what we're dealing with here is what we call a special right triangle. This one in this case is going to be a 45, 45, 90 triangle. And basically some mathematician found out that when you have a triangle composed of these angles, there's a certain relationship to the sides in all of those triangles, and that's what we're going to talk about now. Okay, so someone found out that no matter kind of like how you scale down or scale up a 45, 45, 90 triangle, these are going to be the relationships of the sides. So it's going to be x to square root 2, or x to x square root of 2. And like I said, those are just going to be the relationships of the sides that correspond to these angles. So one of the 45-degree angles is going to have a side that corresponds to this value here, x. So just draw that in. We have 45, 45 here. So like I said, these two sides are going to be equal, which again is reflected in this relationship, right? X is equal to X. They're going to have the same value. So this side is going to be equal to X. This side is also equal to X. And then the side that corresponds to the angle 90 degrees is going to have the measure of X square root of 2. Okay, so in this sense, since it just gets tricky, I would rather think about this in terms of like x square root of 2 and just change this variable here. I'm literally not changing anything. I'm just saying that this side is now going to be equal to y, because if I don't, then that's just a lot of x's. It makes it confusing. So I'm just going to refer to it as a different variable, which is totally fine. Okay, so since we want to know one of these sides, right, what they actually mean, I need to figure out what x is in terms of y, which makes sense because, like I said, I'm just going to rename that the side of the triangle y right here. So that's y, and we also know that this side y is what they give us, or what we give it, is also going to be equal to x radical 2. So since I know that y is equal to x radical 2, I want to find one of these sides, right? Because like I already established, one of these sides is going to be equal to my radius. They're going to have the same length. So since my radius is equal to x, I want to find what that x is. So basically I'm just going to divide both sides by radical 2. So we have x is equal to y over radical 2. Now, you may have already dealt with this, you may have not. There's this concept in math where we don't like having radical numbers in the denominators of fractions. Don't ask me why, but it's really simple to get them out. You just have to multiply by what's called its conjugate. If you get into more complex problems with radicals being in the denominator, it gets a little bit more complicated, but this really isn't too bad. You just have to multiply both the top and the bottom of this fraction by radical 2, and we'll see why. Basically, it's just going to cancel out that radical 2 on the bottom so that we no longer have a radical number in our denominator. And again, we can multiply by radical 2 over radical 2 because that's really just a different form of 1, right? Okay, so now we have this here. Y radical 2, just multiplying the top, and the bottom, radical 2 times radical 2. It's going to cancel out those radicals, and you're just left with 2. And that is, in essence, going to be our answer. If you want to think about it this way, since we have this y up here, and we had replaced it with x already, technically the answer would be in terms of x, but that's totally fine. We still get to the same exact answer. I just did that to make it more convenient and a little less confusing, or else we would have been dealing with like 2 different sets of x, and that's kind of weird. So, okay, so that is that question. Just kind of looking back on it, obviously some things you need to know in order to solve this, and if you didn't know it, some things that you definitely should take away are the special right triangle relationships, 45, 45, 90, and the corresponding sides. Those are going to be super important. Kind of related to trig, but like trig on a lesser level, because it's still dealing with the ratios of sides, right? But we can use 45, 45, 90 when we have less information about a triangle, I guess. And actually, we're going to be going over trig for next week. So this is a little kind of precursor to dealing with right triangles, which is super great. It's going to be a very fun time. Trig is wonderful. But yeah, that's that problem. Make sure you know that relationship. Obviously, you need to know how to do that, but that's kind of like a side, side skill with it. But yeah, that is number 4. We'll go ahead and move on to number 5, and depending on how much time number 5 takes us, this might be our last problem. So we'll just see. Okay, so this problem gives us this diagram where basically we have a smaller circle tangent to a larger circle on the outside. It tells us that the radius of the larger circle is 75% greater than the radius of the smaller circle. It tells us that the radius of the smaller circle is going to be 4, and it wants us to find the area of the shaded region in that diagram. Okay, so really the first thing that we have to do here, and we're honestly kind of just dealing with area in this problem, which is really nice, because a lot of the other problems that we've done so far have taken obviously concepts from a lot of different places, but this is basically purely circles, a little bit of proportions, but not bad. Okay, anyways, the first thing that we're gonna deal with is this problem of the radius, right? Because we do need to find the area of the larger circle in general. We know that. That's gonna be important in this problem. So in order to know the area of the larger circle, we have to figure out the radius of the larger circle. And it doesn't come out flat and tell us it, which is fine because it tells us information that we can use to find the area of this larger circle by finding the radius. So it tells us that the smaller circle's radius is going to be equal to 4, right? And it tells us that the radius of the larger circle is 75% greater. So basically what I'm going to do is I'm going to multiply the length of my radius here by 1.75. And the reason that I'm going to do that is because, or I guess kind of like how I get to that 1.75 is I have 75% here, right? I know it's 75% greater than. 75% written in decimal form is just 0.75. So now you may be asking, okay, why don't we multiply by by 0.75 instead of 1.75? And the reason behind that is in the wording, and it also is just kind of logical, right? It tells us that the radius of the larger circle is 75% greater than. So I know that I have like this one here and this one here that I add is really just going to be represented by, or I guess it represents the full radius of the smaller circle. But if I were to just multiply by 0.75, obviously it would give me a smaller number. But that would be taking 75% of our radius when we want to know what the length is of our radius that is 75% greater than 4. So that's why we multiply by 1.75, and when we do so, we get 7. So now I know the radius of my larger circle is going to be 7. So I know that the basic formula for finding the area is going to be a is equal to pi r squared. So I'm going to go ahead and plug in my larger radius into this equation to find the area of my larger circle. So once I kind of simplify that down, we just get 49 pi for our larger circle. So basically what we have to do now, 49 pi represents, like I said, the area of our larger circle, but that would be like the area of that entire larger circle, right? But that's not what we want. We just want the area of that shaded region. So if we look at it, the area of that shaded region is the area of the entire circle minus the area of the small circle, right? So now we just need to find the area of the small circle, subtract the two numbers, then we're going to get our answer. So again, we have a is equal to pi r squared. Now we know our radius is 4. It already told us that. So now 16 pi is going to be, like I said, the area of my smaller circle. So I'm just going to subtract those two values, and I get 33 pi for my answer. Awesome. Okay. Just kind of looking back on that problem, obviously you don't have to write that out. Just to find the larger radius, you can really just kind of type that into your calculator if you recognize it. Obviously you don't have to like write out the areas. I would, however, leave the pi in there. I believe we talked about this before, maybe not. But most of the time, ACT is going to prefer you to leave irrational numbers in kind of the easiest form so that you don't have to like round off with a decimal. So you're most of the time never gonna multiply that pi out. You're just gonna write it in there because that's the most precise answer, right? If you round off, you cut out some of the preciseness, and it's just a lot easier to write it like that. So yeah, just kind of figuring that out. You just have to like look at what format the answer choices are in. Same thing goes with like the radical that we had done before. We could have multiplied radical 2 out, right? But then it would have given us kind of like a weird number, a weird irrational number. So make sure you're just looking at the answer choices and you're conscious of that. And yeah, just kind of adjust depending on what the answer choices tell you. Awesome. Okay, so yeah, we really only have a couple minutes left. So we're gonna call that time. Like I kind of alluded to in here, next week we're going to be dealing with trigonometry. So that is page 4 on your math packet. I'll just kind of give you guys some words of encouragement, some words of advice with that. I would recommend looking ahead at that just so that when you come to class, you're not like totally out of the loop. You at least know what we're talking about in a sense. But I'm gonna do my very best to explain the actual workings behind trig and why we use trig. Because I know personally when I started learning about trig, either through like ACT classes or through school, I understood the concepts, right? Like sine is equal to opposite over hypotenuse. I can kind of apply it if the problem is easy enough, but I did not know what the heck I was finding. Like I could do it, but I didn't know what I was doing in essence. And that's just really difficult because it requires you to like remember a bunch of stuff, and it's just harder to apply that stuff if you don't actually understand the logic behind it. So that's why I'm a super huge proponent of actually teaching you guys the reasons behind why we do everything, but specifically in regards to trig, because I know that is not everyone's favorite subject, but it can be if you know actually what's going on behind it, because it's pretty cool, very helpful for a lot of different problems if you actually know how to use it correctly. Okay, so that is everything I have for you guys this week. And like I said, we'll just see you guys next week talking about some trig.